Hajimemashite. It's really nice being here. I'll have to switch to English because I've just arrived here 5 months ago, so my Japanese is not yet good enough. So thank you for being here. Please switch the slide. Oh, thank you. So usually when I'm having HoloLens presentations, I'm the only one in the room having a HoloLens, and everyone else kind of watches. It's amazing for me that now I don't have a HoloLens, and a lot of you people have one. So it's amazing being here. Thank you, guys. Thank you.
Welcome.
I'm a Hungarian software engineer. Previously, I worked at Accenture. I started just kind of at the moment when HoloLens arrived, and since then, and until I left the company and came here to Japan, I was developing HoloLens applications and other applications for Accenture. Now I'm here, I'm doing kind of an internship at NTT Data based on a bilateral agreement between the European Union and Japan. So now I'm here until August. Please switch. Alright. I was very lucky because you all know the major use cases for mixed reality, and I was lucky to work on almost all of them in various projects, and also in projects that kind of combined all of them. Because it was Accenture work for most of the time, there are projects about which I cannot really speak, but there are a couple of public projects, so I would like to present those. And also there are a couple of thoughts that I wrote down. I wasn't sure like how exactly will the public be, so like we will see if we will be able to talk also about those. Whenever you think so that like a couple of things that I'll present are kind of subjective, so after I finish, please come to me, let's discuss it, let's have a little debate, and we'll see afterwards. So the first application is kind of an industrial worker application. The main idea is, you do know that training and remote help is one of the major use cases in an industrial field for a HoloLens and any other MR device. It's okay, we will get there. We will get there once again.
Okay. ちゃんと仕事してよ。
Yes. The main idea of this application is that whenever a new hire at a company, at a different factory, goes into work and he doesn't really know a tool, a machine, he can just look at it with the HoloLens and he can recognize it using different image recognition technologies. Based on the recognition, he afterwards will be taken to the model of the specific device. The model has a description, the model can be taken to pieces, the model can be analyzed, and so on. I've in this project and also in other projects, we put the accent in combining various technologies that kind of give value to specific projects. HoloLens is one of these technologies. HoloLens is great for interfacing other technologies, so that's why we combined HoloLens with TensorFlow, with AI, with machine learning, and we're combining it also with IoT and with different other technologies to get the most value to the industrial field. In this case, we use TensorFlow. We use custom class recognition. This means that we had a neural network already trained and we did a retraining. I guess some of you might be familiar with this. We took the last layer, we peeled it off, and we built our own classes based on this. What this means is that we are able to recognize our own classes when we enter a factory and we are looking at electrical engine A. We'll be able to recognize it. If we'll look at electrical engine B, we'll be able to recognize it because there are different types, and if we have good enough training data, we can recognize it, we can get to the description, and we can take it apart, and we can give value back to the industrial field. Okay, switch please. Alright, this is also an open project kind of, that we were doing with Accenture. It was more like a proof of concept. The idea was, how would it be if we could give HoloLens to visually impaired people? HoloLens is a great tool. It can make things possible that weren't possible until now. So what if we could help people who kind of need help? This was the idea behind the project. And the idea was, let image recognition with beacons, with sonars, and with HoloLens technology work together. Based on the previously discussed pattern to just recognize different tools, different things that are, for example, on a table. Our goal was to recognize different types of money. If you are a visually impaired people and you are at a shop and you are getting back a 1,000 yen bill and a 10,000 yen bill, you should be able to look at the bill and recognize what bill it is. You shouldn't need to like touch it to figure it out. You should be able to recognize all of everyday items just by looking at it. You shouldn't need to be able to touch it. The second, the sonar functionality. You all know the various strengths the HoloLens has, and one of these is that it can really nicely map all of the surroundings. If you combine this with kind of a sonar functionality, you can very easily make kind of, you all know the cane that they usually use. You can drop the cane because you can just look at a specific surface and you can get back an auditive feedback related to the exact distance to that specific point. Also, one great tool that the HoloLens has is that you can measure the angle of incidence of the raycast. So, if you have the angle of incidence, that means that you will be able to know if it's a horizontal or a vertical surface. And this is very important because I can look at the wall and I will know that it's a wall. I can look at the floor and know it's a floor. And if there's a staircase, I can look at the staircase, and based on the change of the sound, we change the pitch of the sound. Based on the angle of incidence, you will be able to hear that that is a staircase there, that you will be able to go up or go down. This was the main idea. If an object was close, it worked kind of like a parking sensor. If an object is close, then it's beep, 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 beep. And if it's not, beep, beep. And if it was horizontal, it was one tone. And if it was vertical, then it was another tone. That was the main idea behind the sonar functionality. It works mostly in indoor environments where there are not many people, because like the refresh rate is not yet good enough. So like if people are moving around, it's not very easy to grab the exactly correct surfaces all the time. But for your own little room at home, it works perfectly. Also beacons, like I mentioned already before, that we want to combine good technologies together. Beacons are also one of these. The idea was that if you are going to a public space, if you are going to the mayor's office, if you have to pay something, you should be able to walk there and get a notification that you are now at the payment area, you are now at the lavatory, you are now at the entrance area. You should be able to get these informations. You shouldn't have to like grab the wall and find different subscriptions all the time. All right, please. Another project that we worked on was kind of a factory overview. Like one of the buzzwords now in the industry is digital twin. I'm sure all of you have heard it. And because HoloLens is so good at interfacing with other topics, it's an ideal interface for a digital twin technology. For a digital twin technology that I think will kind of influence the coming years of technological evolution. If you've seen the HoloLens demo that was outside presenting a manufacturing process, what we did was kind of similar, also with a little bit more of data visualization. HoloLens is also quite strong on that side. So because it really easily manages 3D data, you can build various 3D graphs really easily, and you can visualize almost anything and really easily change it as you wish. Okay, the next one. I don't have that much time, so I will go to a couple of the thoughts, and I want to present to you like one thing, like the first time I heard about Japanese HoloLens developers, because I heard that, yes, that was the slide. The main idea is that it's really nice. I mean, this is my first time when I'm at the HoloLens meetup, because until now, various big companies like Accenture, let's say also Microsoft and so on, in the places where I worked, kind of kept to themselves. Everyone was doing the development by themselves, meaning they didn't really collaborate, knowledge wasn't shared, so everyone had to do the job by themselves, and the rate in which we could go forward was lower. Here, having these meetings is like an enormous advantage. I think it's amazing what you guys have here. The first time I've heard about Japanese HoloLens developers was in the first months I was developing for HoloLens, and I was searching for a networking solution. And I found a blog post about Microsoft Hackathon, where they also needed a networking solution. Next one, and you will see this one. He was also searching for a networking solution, and he found Japanese developers' code somewhere, and he managed to solve his networking issue based on the Japanese developers' code. So it's possible, yes, language kind of raises a couple of barriers, but HoloLens kind of brings us together. So like if we take anything away from this little session, then that should be it. Please go to the last slide. Okay, the last one, because there are a couple of more. Just go. The one before the last. More. More. Yes, stop here. Okay, these are various ideas, but my time is up. We will see what the future brings. I'm really hoping that we will have some competition in the field so we can grow even faster. It will be amazing if Magic Leap and maybe a potential Apple device will come out. We will see how that goes. And the last slide. Arigatou gozaimashita. Thank you very much.
はい、皆さん、素晴らしい日。ちょっと若干スライドの順番とちっちゃいましたけど、皆さん多分英語ちょっと得意だと思うんで、はい、きっと全部分かったと思いますんで、はい、よかったです。はい、こういった English。Anyway.
Everyone's good at English.
Thank you.
皆さんの冷却サウナ回ってる。
今日は、LT 第1部の方、そちらにそろそろ準備の方をお願いします。どのぐらいに始めましょうかね。10分ぐらい、じゃあそうですね、10分後に始めましょう。宮浦さん、浅木さん。
じゃあ4時40分から、第1部、レッ